Hello, welcome back to the rectangular and jagged multidimensional array segment. I have to apologize that I had to stop the recording earlier. I had an error that happens rarely, but when it happens, it's really interesting to find. In particular, my two new methods, output array first version for rectangular arrays and output array second version for jagged arrays, ended up by mistake being coded within the main method. That of course is incorrect. So the main method is a method on its own, so it ends when the second output array call ended. And of course the additional new method, the two output array methods, have to be coded outside of the main method. So that was the error that caused my difficulties. So having found and corrected that, here is the code, this time without an error, new and improved, so to speak. And so nothing changed other than the fact that the two methods are now outside the main loop. So having said that, let's try to compile it, build solution, and having done that, let's run it with Ctrl F5, and then the output appears as expected. It's really a simple program, so shouldn't have caused that many difficulties, but it did. So values in the rectangular array by row are, and they are listed due to the call of first rectangular output array call, and then secondly the jagged array is also displayed in response to the second invocation. And what is important to remember here is that output array has two versions. They are overloaded. So while they have the same name, one is takes an input parameter of a rectangular array, and the other takes an input parameter of a jagged array. And they have the same name, so they form a pair of overloaded methods. They are different because their signatures are different due to their different argument lists. So the program works now in this version, and that's the output again. So having done that, let's continue. There is a case study using rectangular arrays, which we can skip for now, and move on to one of our last topics here, and in particular to variable length argument lists. These allow us to create methods that can receive an arbitrary number of arguments, any number of arguments in particular, and the modifier can occur only in the last entry of the parameter list, as shown in a method called average in the following program. So this is the parameter array test. Calculate average is our first method, average, to which we are passing in an array double numbers, and the param specifier indicates that an array of parameters will follow whose size is not defined at this point. So then the body of the method follows its code block. We need a variable of type double initialized to 0, and then a for each loop adds up the all the numbers that are part in the array numbers. It's an array of doubles, and passed in as params indicate that an indefinite or undefined number of parameters follows. And then we return the total divided by the length of the numbers. This time there is no need to cast because total itself is double in type, so when we are dividing by an integer, the result will still be a total. In the main method, we just a test declare 4 double numbers 10, 20, 30, 40, and then we display the 4 numbers as d1 equals, and it's a floating point. Each one is on a new line, and then we call average 3 times with different number of parameters. In particular, first we call it with 2, like average d1, d2, and then average d1, d2, d3 with 3, and finally with average d1, d2, d3, d4. And as we can see it from the output, it actually correctly computes the average of the first 2, then the average of the first 3, and finally the average of all 4 numbers correctly, depending of how many values we passed in. So this is allowed by the params specifier or modifier, which can occur only in the last entry of the parameter list. In our case, there is only one entry, so that modifier appeared there, but we could have had a fixed number of parameters before it. But before the last entry, we can put params saying that a number of arguments follows here in an array that size is determined only at the time the method is called. Note also that whenever writeline receives fewer arguments than specified in the format strings, then it displays only those that it received. The others that are not present will be ignored in the output. So that's our way to use multiple arguments without having to rewrite the average method, for 2 numbers, for 3 numbers, and 4 numbers. It could have been overloaded, 3 times, but it's not necessary because the params modifier allows to pass in an array of arguments as long as they are the same type as shown here. And finally, in this segment, we look at command line arguments. These are passed into an application when it's run from the console window, and it's a parameter of type string array, so it's an array of strings. It's called args, and the number of arguments on the command line is accessed from the length property of this array. The command line's arguments separated by white spaces, meaning that a space or a number of spaces or tabs, anything that creates an interruption of characters but not commas. So the program that we are going to write uses 3 command line arguments to initialize an array. So here is the program, and it assumes that this program will be run from the command prompt, and therefore utilizes the args array, which is an array of strings. This been present in in our main method, but we haven't made any use of it up to this point. it is useful only when we use command line argument. So what we do with it is we check its length. If args.length does not equal 3, which this particular program assumes, then we write an error message. Error, please re-enter the entire command, including new line, the array size, initial value, and increment. So we require 3 arguments exactly, and if it's not 3, then we get an error message. Otherwise, assuming that we are passed 3 arguments, then we take them one by one. Arg0 is the first one, and we convert it to an integer, 32-bit integer, because those are all strings, so they have to be converted if we want numbers. So the first argument by our convention will be standing for an array size, and therefore we assign it to the variable array length, and then create a new array called array actually with that length. Then we use the second and the third arguments, also converted to integers, so args1 and args2. The first one assigned to a variable initial value, the second to a variable increment. And then we use these variables to create values of the for our arrays. So in a for loop, counter running from 0 to 1 less than array length and incremented, the current element of the array will be the initial value times the initial value plus increment times the counter. So we increment every time by the amount of increment as we started from an initial value, and console write line for the output, and our 2 parameters are the index and the value, and the value is 8 characters wide, so that creates our headings, our kind of title line. And then in a for loop, counter initialized at 0, running less than 1, the length of the array, and next to each other the 2 arguments 5 wide and 8 wide. The first is an integer, the second is a double, and we do it for every element of the array. Here are some outputs of the running results. Init array is the name of the program, .exe. We invoke it from the command line, however no argument follows, so our error message will appear. Please re-enter the entire command, including the array size, initial value, and increment. Since in the if part there's no more command to execute, the program just terminates, and the user have to retype initarray.exe and add the appropriate values. So here are 2 examples of successful runs. So initarray.exe and the command line arguments are 5, 0, and 4. So 5 is the number of elements that will be displayed, so 5 lines of output. 0 is the initial value, so we start with 0 and we increment it by multiples of 4, so the 5 values will be 0, 4, 8, 12, and 16. The second run uses 10 as the first argument, so 10 lines will be displayed. The initial value 1, so we start going up from 1 and by multiples of 2. In other words, we are really printing the first 10 odd numbers starting with 1, so 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. So that's the use of the command line arguments. And one more time, the command line arguments feature works only if a program is run from the console window as shown. So we have to be in the right location. In this example, the program would be in examples C colon backslash examples backslash chapter 8 backslash figure 8 23. That's the folder in which the exe file itself is located, and only then we can run init array as a program. And if you put in the correct 3 arguments, then it executes the loop as we specified.